Hello guys, I'm currently presenting my screen which says how to build neural network in Python. The agenda which we're going to cover in today's session is we'll try to understand what Python is, we'll try to understand what is neural network, we'll try to understand single layer perceptron, multi-layer perceptron, and we'll also try to understand some applications of neural network as well. I have a small hands-on notebook as well, and that is something which I worked out using Jupyter Notebook, which is an IDE for Python. So this is the agenda that we have, and this is where we are going to begin today's session. So Python is an object-oriented programming language. Okay, you could do a lot of things using Python. Okay, so Python is not only used for data science related work. You could do application testing. You could do what you call it as you could build web frameworks as well for using Python, and you could do basic data analysis as well. You could write there are different things. Testing is one other thing, application development, and there are a lot of things which you could do using Python. But the thing which we want to focus for today's session is we are going to understand how you could use Python to build neural networks. Okay, there is something called as artificial intelligence. Okay, consider that as the largest subset. There is something called as machine learning, and there is something called as deep learning inside machine learning. Okay, although machine learning and deep learning are quite different. When I speak about deep learning, these are essentially built using the architecture of neural network. So a neural network is a combination of input, output, certain layers, certain hidden layers, using which we actually try to develop deep learning algorithm. It is a subset of artificial intelligence, and it is an extension of machine learning. If you ask about data science, which is also a subset of artificial intelligence, and NLP is also a subset of artificial intelligence. Okay, these are different terminologies which you might have heard at some point in time. But the one that we are most interested in is in neural networks. Okay, we are going to build basic neural network using Python. As I have already said, Python could be used to do to work on a lot of things, and data science or machine learning or deep learning is one of them. Okay, that's what we're going to cover in today's session. So, what is Python? It's an open source programming language. Okay, it is, as I said, it is based out of object-oriented programming concepts. Okay, it was developed by Guido van Rossum in 1989, and of late this has become one of the prominent programming language owing to its simplicity, owing to its capability of deployment, and it has been used by large organizations as well for doing a lot of things. Okay, the features of Python, the people who aren't aware much of Python, Python is really simple to understand, owing to its let's say simplicity. I would say if you are doing the same thing in Java and in Python, you would find Python to be much more suitable than Java because you will have to write less codes as well. Since it is open source, it has a lot of community support. So any particular problem that you're facing when you're working on Python, you could actually get a solution just by Googling it at your fingertips. Okay. You could also contribute to Python library if you feel like you are able to build the Python library after getting some amount of expertise on that, you'd be able to do that as well. Okay. The features of Python, portability. It is a very portable language as well. You're developing some codes, you could actually publish those codes and you could actually use this to build a mobile application as well. It has a huge set of libraries in a sense that you could actually do a lot of things using scientific. You could do scientific calculations, you could do visualization, you could do machine learning, you could do deep learning, you could embed different frameworks of machine learning, different frameworks of deep learning, and so on and so forth. Okay, it is object-oriented programming language. It will you are free to build your own classes and methods, and doing this you could do a lot of things in Python as well. Okay, now coming to the important point, what is neural network? I'm not spending much of a time in Python because these are some of the things which you'll be obviously getting in the internet. The point which I'm trying to drive is there are a lot of ways of building a neural network, and Python is one of them. and Python is one of the famous of them, I would say. Okay, one of the programming languages which is used very often. There are different other things as well. Like you could do it using R, you could do it using GCP, you could do it using Azure, you could do it using AWS as well. Okay, those are the other things that you have, and apart from that, you have Statistica, you have what you call it as SPSS, you have SAS as well. Okay, now what is neural network? Neural network are essentially certain combinations of architecture that we have, and when we are actually building a neural network, what essentially we are doing is we are combining certain layers. Okay, we are combining certain layers and we are combining certain inputs to get a desired output. A very simple way of understanding neural network is comparing neural network with the neurons that we have in our human brain. In fact, neural network is the term that has been derived from the specific term called as human neuron. So how does a human neuron work? If let's say a very bad example I'm going to give you. Let's say you could see a particular mosquito sitting on your hand and trying to suck blood out of you. What will be the obvious reaction to that? You'll be having your other hand take a swat at that particular mosquito. So what happens is you see that mosquito through your eyes processes that signal, it sends a signal to the brain. Since you'll be going to get a biting sensation, that is something that you know by your previous experience, your other hand or your alternate hand on which the mosquito is not sitting, you'll try to raise that hand and try to swat that mosquito or try to sway that away. Okay. Now, when you are doing that, your brain is sending another signal to your alternate hand to do such things. Imagine all these things are happening within nanoseconds or within frames of seconds. This is exactly what the computational power of your brain is. Okay. Now, this is something which a computer is trying to replicate. And when it is trying to do that, it is trying to act upon certain events. Okay, it is trying to act upon certain events. It is trying to understand what are the necessary patterns, what are the necessary analysis that it needs to do. For example, if I'm giving a million points of observation for people who are diagnosed with diabetes, if I'm feeding that particular information to a computer, or if I'm feeding that particular information to a neural network, the neural network is actually capable to develop a particular mathematical function which will represent that particular million observation that I have sent. And with that particular mathematical representation, it will be possible to make certain predictions whether a particular person could be diabetic or not, provided you are sharing the historical background of the particular person to that particular neural network. This is essentially the crux of neural network. Previously, you would be designing an algorithm. Okay, for neural networks, you do not have to tell them what needs to be done. It has certain intelligence of its own. So when I say it has certain intelligence of its own, that is exactly we call this as artificial intelligence. When it is actually going through those lots of observation, it is able to understand those patterns. It is able to build that mathematical function from that particular pattern. When it is actually doing that, it has something which we call it as a feed forward network. It learns from its own mistakes. It does these mistakes, it learns from that, and it corrects those mistakes as well. So there is something called as iterations which happen inside the neural network. When I speak about iterations, these are essentially training iterations which happen inside the neural network. When these training iterations happen, the neural network understands what is correct and what is incorrect. And accordingly, after comparing the correct and incorrect results, it is actually, let's say, it is actually trying to rectify those mistakes which it has done in the previous instance. Okay, this is exactly what happens inside the neural network. So this is how a neural network looks like. And yeah, when speaking about the motivation, this is what I was discussing. What is the motivation behind a neural network? We had discussed that a neural network is essentially something which has a very good amount of likelihood or a very good amount of, say, similarity with a human neuron or the neuron which is present in our brain. Okay, so I'll show you one slide, not slide exactly. Yeah, this is what I wanted to show you. Just hold on. By the way, I'm showing my Jupyter notebook, guys, in case you are not able to see. So this is the simplest representation of a neural network, guys. Okay, you have these inputs over here. There will be certain weights which should be assigned. There are certain biases as well which you could add. These weights and these inputs are added over here, and a bias is added. It is passed over an activation function, and we get an output. Okay, so we have inputs, we have weights, we have summation and bias over here. Okay, so what this does is, let's say if you want to predict the temperature for tomorrow, you could actually build a neural network for that, provided you have the necessary data. Okay, so this is the input node. You could actually attach different hidden nodes here as well. This is a plain simple neural network, and hence it does not have any hidden network. Okay, if I have to show you a neural network with a hidden layer, this is how it will look like. These are again the input neurons, x1, x2, x3. This is the hidden neuron that we have. Okay, this is the hidden layer actually. You could have multiple hidden layers. Okay, depending upon the hidden layer that you're going to have, you would be having something which we call it as either a deep neural network or a shallow neural network. The very basic neural network which we had seen previously, this one, is something which we call it as a perceptron. So when I say perceptron, the difference between a neural network, artificial neural network, and perceptron is it does not have any hidden layers. So it has input layer and it has an output layer which you are getting with the help of summation and activation function. Okay, we'll speak about summation and activation function in details. When I speak about multi-layer perceptron, or when I speak about artificial neural network, it will have at least one hidden layer and it will have a lot of connections as well. So when I say connections, you will have different connections flowing from input neurons to this hidden layer. These connections are something which are absent in case of a single layer perceptron. You could see that. Okay. Now, where exactly are neural networks used? One of the common examples of neural network, that is something that I believe you must have been familiarized with, is convolution neural network, or at least CNN or ANN, artificial neural networks. Now, when it comes to convolution neural networks, essentially it is, or like it is mostly used for identifying whether a particular image belongs to cat or a dog. Okay, so let's say it is used for doing a kind of classification technique. So it is mostly related to image-based inputs, convolution neural network. When I speak about an artificial neural network, you could actually predict the amount of rainfall which is going to have. You could actually predict whether a particular person is going to be diabetic or not. So these are some of the things which you could actually do using a neural network. That is what you could see in this particular slide. So artificial neural network are computing systems inspired by biological neural networks that constitutes human brains. Such system progressively improve performance. So when I say progressively improve performance, there is a particular uh, thing which you need to know. There is something called as feed forward. So when I say feed forward, what does this essentially mean is, as and when this particular layers are intertwined, you could see when a particular information is passed on from an input neuron to hidden neuron, and assume that there are a lot of hidden neurons. So this information is passed on in this particular manner. Okay, there are a lot of information which is being passed on from this side to that side. Okay, so as and when this thing happens, this is called as a feed forward. Once this output neuron is generated, and once the result is compared, there is another loop which runs, which is called as a feed, which is called as a back propagation. In this particular layer, understanding happens using which these weights which were assigned gets corrected. So when these weights are corrected, what essentially happens is the neural network architecture tries to learn from the mistake which it has done. Okay, and accordingly it tries to adjust in this particular phase of back propagation. So essentially when I speak about artificial neural network or multi-layer perceptron, these are some of the networks which will have a feed forward and back propagation. And it will have obviously inputs and outputs and activation functions and summation, and it will have at least one hidden layer. Okay, that is the basic thing which you need to understand. Now, what happens is this is something which will help you understand how these things actually work. Okay. Now, these are the inputs for a particular neural network. If I compare the inputs to the human brain inputs, remember the example when a mosquito was sitting on one of your hand. One of the input could be a mosquito sitting on your hand. The other input could be a biting sensation which you're going to get. The other input could be your one of your hand moving onto the other side. So these are different kinds of input that you have. Initially, there are certain weights which are initialized. These are random weights which are initialized by the model. Okay, and using this, there is a processing which happens in which these weights and the inputs are summed up and a bias is also added. Once this particular thing is done, there is a particular function which is added to that, which is known as activation function. This activation function is actually responsible for converting uh, the activation function is mostly responsible for converting linearity into non-linearity. So artificial neural network is actually able to handle non-linearity in your data. That is exactly when you would be needing an artificial neural network or multi-layer perceptron. Okay. Now this is something which is pretty much similar to how a human brain works. That is what we are trying to describe in this particular slide. Now moving ahead, we'll try to see a particular example that I have built for you guys. So a couple of things which you need to know. Types of neural network. It could be a perceptron. Okay, you remember perceptron in which you do not have any hidden layer. It could be a feed-forward neural network. Remember artificial neural network. Okay, in which we are having feed-forward and back propagation. Convolution neural network, in which you are actually using image data and convolving images. You have radial basis function neural network, you have recurrent neural network, you have sequence to sequence model, and you have modular network. Okay, now these are some advanced concepts which we are not going to discuss in details, but the thing which are of interest for this particular session is single layered neural network or perceptron and multi-layer neural network or multi-layer perceptron, MLP and SLP. These are the two things which we are going to mostly focus on in this particular session. A single layer neural network contains input and output layer. The input layer receives the input signals and the output layer generates the output. That's it. It's pretty much basic. This is something which we would call it is, this is so basic that we really do not use it. Okay, this was used initially during the time this neural networks were developed in 1970s and so on, but we were quick enough to realize that these are actually not very helpful. Hence, we have something which we call it as multi-layer neural network or multi-layer perceptron, MLP. Multi-layer neural network contains input, output, and one or more hidden layers. So it will have at least one hidden layer apart from the things which you'll be finding in the single layered neural network. And essentially, if I speak about the perceptron, whether it is single layer or multi-layer perceptron, it will have these common things: input value or input layer, weights and biases, net sum in which you'll be calculating the total sum, and an activation function which is responsible for converting the non-linearity. What is the next thing that we are having? This is how your single layer perceptron looks like. Okay, as I have discussed this thing, this is an alternate representation. It's a simplified representation of single layer perceptron, x1, x2, x3, and y. This is the output that you're getting. It could be 1 or 0 depending on the requirement that we have. Okay, there are certain limitations of perceptron or single layer perceptron, because of which we have moved on to multi-layer perceptron. And when I speak about multi-layer perceptron, there is something called as a back propagation algorithm which happens here. And MLP is basically, I won't say it's a deep learning method, although this term is actually incorrectly used, but this is, I would say, shallow learning method. Okay, this is not essentially a deep neural network. Okay, this is a shallow neural network. If you're having a lot of hidden layers, let's say at least 3 or 4 hidden layers, we can confidently call this as a deep neural network. Okay. Some basic difference between single-layered perceptron and multi-layered feed-forward network is something that I have provided over here. Then you could see that absence of hidden network, not a very efficient architecture. Okay, these are some drawbacks that you have. Okay, when it comes to the differences between multi-layer perceptron and artificial neural network, there are certain differences which you might need to understand. In essence, we also do not use a multi-layer perceptron, okay, because it will have just one hidden layer, one or two. Essentially, the real life applications which you see, let's say WhatsApp, the Gmail applications, or the recommendations which you're getting in Amazon, behind that you'll be finding huge networks. There will be deep neural networks which will be writing, which will have around 40 to 50 layers at the minimum. Now, I'll be using a particular data set which is publicly available. Okay? And I'll be using this particular wine dataset, white wine and red wine dataset, to build a single layer perceptron. Okay, that is the very basic neural network which you will obviously be starting to build it when you'll be starting this particular journey. I have intentionally not kept this particular thing complex because I know most of the people that are attending this webinars are mostly beginners. Okay, and it would help you guys a lot if you could understand the basics of it before you move on to the complex parts. I'm not denying the fact that you won't be able to understand the complicated things, but it is easier for every one of us if we start with the basics. That's the reason I have started with a simple data set where I'm reading the data set. I'm combining the data set over here. So I'll be getting one data set out of my two data set, that is white wine and red wine, and I'm naming this as wine. Okay. If you guys are familiar with the basic architecture of machine learning or deep learning network, you'll get to know that there is a particular split which happens. Okay, so we are splitting the data, and based on this particular split, we'll be using one part of this split to what you call it as train our model, and the other part test our model. Okay, so this is what we are doing over here. We are normalizing our data, and then this is exactly where we are building our neural network. It's a single layer perceptron. This is the Keras library using which we are building it. Okay, these are the two libraries which we need to import. Sequential helps us to initialize the constructor. So this is the first layer, which is the input layer, and this is the output layer that I'm having. Okay, this one is also having a hidden layer, so this becomes a multi-layer perceptron in fact. Okay, so one input layer, one hidden layer, and an output layer. So this essentially combines to give you a multi-layer perceptron. Okay, this is the architecture that I have. Now, once I build my neural network, I'll have to combine my network as well. So this is what I'm doing. I'm fitting my model over here. These are the iterations which are happening. Okay, as you could see, I'm giving a 20 epoch and I'm giving a batch size of 1. So it will run over 20 epoch and it is going to give me some kind of accuracy at the end of this model, which is around 99%. Okay, so I could see this is a pretty fair model that I have built. In fact, a very good model that I have built. And using this, I could actually predict and see what kind of wine that I have. These are some of the predictions that I'm having. I'll be comparing these predictions with my test data, which I already have from the part of the data that I have split. And using this, I could say that this is the validation accuracy that I have got, and this is the training accuracy that I have got. Comparing the training accuracy and validation accuracy, I could say with a greater amount of confidence that these are two of these. This is one of the best model that has been built over here. Okay, so yeah. This is one example of multi-layer perceptron. This is how you could build a multi-layer perceptron. You could improve upon this model. You could actually change some of the steps that I have used over here to make it a bit more robust. Use a different data set and convert this to an artificial neural network. You could add layers. You could add hidden layers. You could add hidden nodes. You could increase this particular layers as well. You could use an initializer. So there are a lot of things which you could do in this particular algorithm, in this particular lines of command that I have written. The ones that you could see over here covers just the basics of it. Okay. Having said that, let's try to see what are the other things that we have in our slides. Okay, activation function. There are different types of activation function that we have, and the activation functions are actually responsible for converting a particular architecture into a deep learning architecture. Okay, they are very much useful, and this activation functions play an important role in the build-up of this deep learning architecture. So, applications of neural network. This is something that you are using on a day-to-day basis, guys. I could give you hundreds of examples. Handwritten patterns. That is correct. DNA mutation. But can you give me some really uh, day-to-day examples or examples of things which are using in your day-to-day life? I know these are correct. Understanding handwriting patterns, DNA mutation, image processing, plant leaf. These are pretty much things in which neural networks are used. But give me some examples of things which are using on a day-to-day basis. Voice assistant, Siri, Google Assistant. Whenever you're speaking with them, there are tons and tons of neural networks which are acting in the background or at the back end, because of which they're able to converse with you with a greater amount of confidence. Yeah, voice search in Google, that's one of them. The other thing, if you are using Amazon using the mobile app, you have a particular feature in Amazon using which you could actually point your camera to a particular object in your house, and Amazon's app is able to give you a image search for that particular item, similar image for that. That is an example of your deep neural network. When you are compiling messages in Gmail, you're getting some uh, prompts, right? You're getting some prompts when you're actually doing that. This is because of the deep neural network models which is running in the background. When you're using WhatsApp, you are getting the next word which you would like to write. There are certain recommendation of the next word which you could actually click instead of typing. How are these things getting generated? Deep neural networks. Autonomous cars, deep neural network. Smart homes, deep neural network. There are a lot of things. Yeah. When you're calling an Ola or an Uber, how does an Ola or an Uber work? How do they know which particular car they need to assign to you? There are a lot of things which gets into the calculation, like the previous rating, the previous time your car had taken, the complaints that you had read. Okay, Ola and Uber are perfect examples where you are using deep neural networks. Okay, is getting rid of spam mail? Yeah, exactly. Whenever a spam comes to your Gmail, it gets automatically redirected, right? At times, certain emails are incorrectly redirected. That is exactly where a machine learning fails to do that. That is another good example where deep learning networks are used. Okay, guys. So I wind up the session now. I hope you guys have got to know at least something from this particular session. Thank you. Have a good day.